share my screen, share my desktop one. Desktop one. No. Okay. Ah, give me one more second. Oh, no, here we go. Yep, I'm ready to share. I'm ready to share. Okay, here we go. Share desktop one. Here we go. Share. Right. Hopefully, I am sharing. Screen sharing. Okay, wonderful.
Okay.
Awesome.
We are live on YouTube now
Okay,
and
wonderful.
recording.
Hello, YouTube. So thank you all for joining us today. Today is a workshop, a training to give you on a tool that a number of people in the Green Software Foundation have been building. It's called cool. It's called Impact Framework. You've probably heard us talk about it, or you've seen some of our videos or something else online. Yep, there's a lot of interest in Impact Framework. There's a lot of people engaged in it. One of the things, I just want to mention this before and at the end as well, one of the things that we're working on. Oh, no, so hang on. Introductions. So, hello, everybody. My name is Asim Hussain. I am the Executive Director of the Green Software Foundation. I'm based in the UK. My background is software development, and for the last, don't know how many years now, we're looking at the intersection of software and sustainability. That's me, my background. Joseph, why don't you introduce yourself?
Okay, thank you. Hi, everyone. My name is Joseph Cook. I am project manager and developer on the Impact Framework. My background's in environmental science. I did a PhD in environmental modeling, then spun out a software company. I've worked on various things, and I've been here at the Impact Framework for 7 months. I'm based in the UK, and it's good to be here. Thank you.
And for those of you in the audience who's listening in, just honestly, it'd be lovely if you just like said hi, like said in the chat, just hi, like who you are, maybe where you are. But I'd love to actually hear and understand kind of like why are you here? Like what's your what are you trying to get out of Impact Framework? What do you want to what do you hope to get out of this session, and why are you interested in software measurement? It'd be lovely to understand. But while that's going on, let me talk a little bit about like a hackathon that we've got running. We've got this hackathon running. It starts in just under 2 weeks now. It's our annual hackathon from the Green Software Foundation. And this year it is about Impact Framework. So this year we're looking for solutions built using, leveraging, enhancing the Impact Framework itself. It's an open source project we have here. And we have kind of quite a few. We've got almost I think 40, and we're up maybe getting to $45,000 prize fund. So we've got quite a nice prize fund at the end of it, so you can win some money as well. And we have quite a few award categories. I'm going to be showing this make a lot more sense to you after this training, but Impact Framework is effectively like a really extensible ecosystem for software measurement, and it's basically but yeah, it basically is it's all about plugins in the Impact Framework. So a prize for the best plugin, and you're going to understand a lot more about what plugins are at the end of the session. There's a type of plugin which is a plugin which can estimate environmental impacts or outputs environmental impacts. And if you can create a plugin which outputs an environmental impact that isn't carbon, with that comes the beyond carbon category. We've got best content. So if you just want to write or just do a case study using Impact Framework and in a interesting domain or interesting way, as long as it's something that's for our content category, as long as it's something that's educational, that would fit into or something that helps people understand how to use Impact Framework, that would be very factor in there. Best contribution is anything that help, even an external tool, but something that makes Impact Framework easier to use for an end user or for a developer, maybe improves the developer experience. That kind of comes into that category. And we also have two other prize categories for best submission from a team made up of just undergraduates, and also, and it's not on here unfortunately, but a best prize for teams made up of under 18. So if you have any connections actually to to schools or to any kind of like more youth software development areas, please, raise it to them, let them know. One of the things that we really focus on the foundation, we say we need to grow the next generation of leaders in the sustainability and the green software space, and that's really what we want to do with the kind of under 18s prize. So I'm just going to like give you some information here. Here you go. That's the link to the actual. That's my wife's picture. I'm sharing her account. Keep on forgetting to change the picture. So that's the link to the actual hackathon website. If you're interested, head here, click on Get Updates, and just sign up. If you've only got time for that, just sign up, and we'll make sure we send a weekly email to kind of let you know what's up. Other link that's going to be very useful to you is the main document. Let me get to the homepage. Is the main documentation page for Impact Framework. So I'm going to share that here as well. We're constantly, Impact Framework is changing quite frequently, so we're constantly trying to keep the documentation updated. It will go into code freeze next week for the hackathon, but for now, like this is a really good resource. And just so in case sometimes people miss it, but they actually, you've got to click on this docs link at the top right here to get to the docs. So in case you want to get to there. And just the final thing, oh, I should have linked this already. The actual hackathon, I haven't updated it since this morning. The actual hackathon is being run via GitHub. So if you do have an idea, if we inspire you somewhat inside this conversation and you think to yourself, do you know what? That would be a really good plugin to write. Or do you know what? I'd love to write some content around this. Or I'd love to see how I can apply Impact Framework to this domain, which maybe we've not thought of. If you've got any idea at all, head to the hack, go to issues, and click on new issue. And that's how you propose a project idea. There's a template there, just flesh it out. You don't have to come in at this point with a fully fleshed out idea. Most people haven't. And just post an idea, and Joseph and I and other people weigh in, and we help nurture your idea to something which aligns fully with the hackathon, because we want to make sure you actually build we want everybody to be a winner. So we want to really help every single person build a great solution. I just want to, if you just got a vague idea, just post it, and we'll help you kind of like understand how Impact Framework works and how your idea could fit in, how best to implement so it fits in and has the best chance of winning. If you've got any questions at all during this session, use the Q&A feature if you can. Joseph's here; he's going to help answer them if he can during, or we'll have some time to answer them live, perhaps at the end. So feel free to raise. And Joseph, interrupt me as I'm speaking if there's a particularly useful one where I should stop to kind of go through it. Okay, let me get my notes up. There we go.
So just before you jump in, there's someone's got their hand up.
Oh.
Can I just clarify, do you mean to have your hand? This is Rip Palomo. Do you mean to have your hand up? If so, can you pop your question in the Q&A so I can answer it while Asim's talking?
Okay. Oh, there's another question here. Does Impact Framework run on a Raspberry Pi Zero? I don't know. That's a great question. No one's tried it on a Raspberry Pi Zero. I don't see why not. If a Raspberry Pi Zero can run a bit of JavaScript, I don't see why it can't run Impact Framework. There's nothing. It's all pretty self-contained. Everything can run. If you use a plugin which doesn't require an API interface or something, then it doesn't even need an internet connection. But I'll explain to you kind of how it works now. Hey, Tammy. Good to see you here. Let me get my thing up and let me get the right window open. Here we go. No, where is that window? Oh, it's over here. Okay. So clear. Oh, give me a second to just get myself together. Okay, B. Okay. All right. So, what is Impact Framework? Impact Framework is quite a lot of things. It's sometimes it's been called a custom emissions calculator. a bespoke calculator that you can create to calculate the emissions you want to use. Sometimes it's called an executable audit. It can be a lot of different things. It's a very low level thing that we've developed locally inside the Green Software Foundation, which has been built up from people who are actually trying at the coalface, actually trying to measure software emissions in currently right now. It's used in a couple of organizations already, at scale as well. And at the core, there's a couple of different ways that you will really interact and engage with Impact Framework. You may interact with it. Number one, you get sent a manifest file. How do you actually compute a manifest file? Someone's computed their emissions and they've stored all their assumptions and everything in a manifest file, and they send it to you and say, hey, these are our numbers. What do you think? How do you run it? How do you look at it? How do you verify it? How do you adjust it? How do you tweak it? What do you deal with it? How do you deal with it? The second one is you yourself want to then also sit down and write your own manifest file, and I'll explain what the manifest file is in a second. And you want to say, I want to compute my own software's emissions. So then I'm going to go through that, how to build up a manifest file from scratch, measuring kind of one kind of simple use case for measuring emissions. And as I said earlier on, like Impact Framework is all about plugins. So I'm also going to show an example of how to build a very basic plugin in Impact Framework. Just to show you kind of roughly kind of how it works and how to build your own plugins, because we want you to build plugins. That's what we need. We need lots of plugins built for Impact Framework. Am I missing anything? No. So at its core, what Impact Framework, how it works, how you interact with Impact Framework is with something called a manifest file. A manifest file is almost there's so many ways of describing Impact Framework. It's almost like a domain-specific language. It's almost like its own language for how to actually write and compute emissions of software. We actually, when we were early on developing Impact Framework, we almost created it as like a language or like an SDK or a library that you can build, but the way people were using it, we ended up just interacting with it using a file instead. So I've just been sent this manifest file from Acme Corp. And they told me, hey, Asim, we've just computed our emissions. This is our manifest file. What do you think? And I'm gonna be like, okay, this is great. I get sent all the time. Like people send me like docs. Oh, I've computed my emissions, and it's a PDF in some bespoke format with every single assumption either not mentioned or mentioned in some weird way. And then another organization sends me theirs, and I'm like, okay, well, that's just two completely. It's like I got sent two poems, and I'm being asked which poem is best, and I'm like, I don't know. It's just two separate poems. What we've worked with the Impact Framework is we standardized the way you write an impact report for an application. So then I can look at two manifest files and go, oh, I can parse this one, I can parse this one, and I can understand how they're different. So I've just been sent one of these manifest files from Acme Corp. What do I do? So Impact Framework is built using JavaScript and specifically Node.js. So I'm going to zoom in a little bit for everybody. So the first thing you would want to do is you need to have at least Node.js version 18 or above installed. That's not a modern version of Node.js, so you're all right. Then you also need npm installed, which is one of the package managers for Node. You want to create like an empty folder. You want to create kind of a workspace on your machine where you can start like looking at and computing the manifest file, because you'll need to install things to actually run it. So let's create a space here. I've created a folder called if demo, and then inside there you want to run npm init. Okay, I'm not going to run this stuff because it's already set up, and I don't want to risk ruining the demo at the start. It's going to run npm init, and that will set up the folder to start using Node inside it. The next thing you need to do is you need to install Impact Framework itself. Now, Impact Framework is actually publicly available on the it's called a Node Package Manager. So it's grunsoft/if. A lot of this stuff is actually in the docs itself, so you don't have to worry. And we'll be sending, not today, but we'll be sending a version of this out, a much more fleshed out version of this workshop with all the commands next week probably. So npm install grunsoft if, and that will install Impact Framework locally in this particular folder. This is how we recommend to run it in this case, at least. And then, you're here. Let's open up the manifest file. It's got a couple of sections inside it. I'm going to very quickly just run through it. So at the top, we've got this part. Everything above this is quite a lot now, but everything above the tree, we call actually, let me zoom out a little. Everything above the tree is what we call the context or the head. This is where you'll have a lot of your configuration, all the things you need that can help you configure to set up impact framework so you can compute the actual tree which is underneath. Then you have the tree and everything underneath there. So the tree is a representation of what it is that you want to compute. So we're running, in this example, we're running we're trying to compute kind of a cloud service. And you can structure the tree however you want. It's completely up to you. But the most important part of a tree, let me show you how it looks collapsed. Server one. Okay, here we go. Server one. So you can see, like, I've just got the tree, which is the root node, and I've said under there's my application. You can have every single application. In your entire portfolio of applications can be a separate node here. The entire tree can be one application. The entire tree can be one server. It's completely up to you. The tree isn't important. It's just a personal choice you have for how you want to group and structure things to make sense of your impacts. So I've got application. This is a cloud application, and so I've decided to group it under the region that these servers are located in the world, so UK West. And at the bottom, you can see these are leaf nodes. These are what we call component nodes, and these are what we call grouping nodes. Component nodes have inputs, which I'll go through in a second. But the way to conceptually think of component nodes are things that can generate emissions, things that can generate impacts. And that's what you put into a component node. A grouping node is just a grouping. It doesn't generate anything. So I've got two component nodes here. I've just got two servers running, and they have inputs. So that's what you provide. You need to capture what we call some observations about the server. Yeah, so this is an array. So you represent an array in YAML. So this is one element in the array. So this element, one of these elements we call an observation about something. Like, I literally think of it like a human being is like observing something. Like, you're observing like a thing, and you're probably staring at it for an amount of time. So like the time you started staring at it is the timestamp, and how long you're staring at it is the duration. So that's kind of the observation. And an observation we have here about this server one is that the utilization was 89%. This is in seconds. So for this time and for 5 minutes during that time, the utilization was 89%. And I have some other interesting observations here that are going to help me with the computation. I know I'm running on Azure. I know the region is UK West, and I know the instance type is a type of cloud instance. If you're using Azure, this would be how you. So this is one of the types of servers that you can buy off Azure. So then that's one observation, and it can have as many different things. It must have a timestamp and duration as a minimum, but everything else is variable, and it's up to you. It's whatever you can observe about your running system. And so we have quite a few observations here for this one server, and for server two, I have quite a few other observations here as well. Okay. Okay, so just roughly explaining to you what that is. I'm going to go through a lot of this stuff in a bit more detail soon. So what I want to do now, so I can see I got sent this manifest file. I can kind of see the structure of it from the tree. I need to compute it. So how do you compute it? Well, the way we recommend here, if you're installing IE locally, is you use a command called npx IE. We call the command line for Impact Framework Impact Engine. It's not Internet Explorer, it's Impact Engine. So you type npx IE, and then the command is --manifest, And then I'm going to pass in the actual manifest file. And then the output is, right now, the output is an output folder that you want to output to. And there's just some error messages coming from one of the dependent libraries, not one of ours. So I'm just getting rid of those to not create too much noise here. So now I'm going to run this. Okay. And now I'm going to open up, and I'll open it to the side actually, so I don't get confused. Okay. Bring that down a little. I'll have to zoom out. I do apologize. So you can see here, like the right-hand side looks very similar to the left-hand side. This is the output file. I'm going to collapse this a little bit so you can see what's going on. That's weird. It's not collapsing in the way it should collapse. Oh, I broke Visual Studio. Let me do that again. I broke Visual Studio. Have I broken Visual? No, it's working now. Okay, it's working now. I think. There's a tree. The fudge? Anyway, I can't collapse things, so I'm gonna have to show you what happened. So you can see we've got server 1 and we've got the inputs node, but if I scroll down, we now have an outputs node. And the outputs node now has a lot more information. This was in the original, but you can see now it has a lot more information there. And very importantly, at the end, we now have a carbon value. So this is saying for this 5-minute period, this server emitted 0.31 grams of carbon. And if I go to the next observation, it went to 0.26 because the utilization changed and it consumed less energy, I presume. So that's how it works. That's you have a manifest file and you compute it, and then it generates the impacts, and it's all just fully well, let me explain exactly. Let me explain how we got to carbon. I keep on forgetting to explain this. Let me explain what's going on here. In fact, that is confusing. Let me get rid of that. And that. So what happens in impact framework is this concept which we call induction. So you had an observation that you gathered about something, and the task you have before you is to convert this into carbon, and we call that process induction. So we call the process of taking something you can observe about the world and turning that into carbon or any other impact. That process of taking an observed thing you can see to carbon we call induction. So in this case, we've got CPU utilization, and we want to turn that into carbon. That process is called induction, and that happens through plugins, a series of plugins that exist in a pipeline. So I'm just going to scroll up a little bit so you can see here. In the tree, we've configured 4 plugins in this case: powered metadata, Teeds curve, watt time, and operational carbon. What's going on is we're passing in this observation, just literally this data, to the first plugin. They've all got standardized interfaces. Whatever that outputs, and it outputs something that looks like this, but with a bit more data, is passed to the next plugin, which then does its job in that whole story of turning utilization into carbon. And this outputs something which then costs to watt time, and the watt time plugin does its job in slowly transforming that utilization into carbon until finally the operational carbon plugin does its job in transforming it. This is how induction works with Impact Framework. And the really key thing is that each of these plugins does just one job. They're very tightly scoped. They do one job, and they do one job very, very well. And think of them like a Linux command line where you have like lots of commands with a pipe character, and you can create very complex functionality with just a few little programs that you structure together in an interesting way. This is one of the the breakthrough moments in Impact Frame was when we realized we needed a pipeline of plugins. We first started off thinking we just needed one plugin for every single thing, but we realized actually that doesn't make sense. You actually need to use lots of plugins in a pipeline together. And that's a really powerful part of Impact Framework, because it means that if you want to do something a bit different, you don't have to create a whole model and thing from scratch. You just change one plugin in this curve, and each of these plugins are like they all have the same interface, so you can swap them in and out, just like the same way as you can swap a plug in and out of a socket. You can just swap them in and out, and they'll just work reasonably well together. There might be some caveats there you have to think through. So now, but like you've just been sent this manifest file, you've computed them carbon impacts. But here's a few things. Like, you might not agree with how they've decided to compute. And this is something that comes up a lot. I always say, like, people say, like, is this right or is this wrong? And I'm like, this isn't right or wrong. This is just your opinion versus somebody else's opinion. You both might have very valid reasons for choosing different approaches to measure something. Um, one of you thinks the other one's wrong. The other think the other one's wrong. There's just different opinions. And so with the manifest file, we see what your opinion is. We know fully every single assumption that you made, every single coefficient, every single input. I might say to you, look, I would go about this a different route. I can see that you've used WattTime, and WattTime is a service that tells you how clean or dirty the electricity is, and you need it in order to compute how the carbon from the electricity. So it's kind of a third-party service, and it gives you very granular data. But you might not agree with WattTime. You might not agree with their approach. You're from a regulatory reporting perspective, somebody might tell you, do you know what? You have to assume this is how clean or dirty electricity is. We're going to force it. So you might have like a different approach. So you would then go, so WattTime does is it outputs grid carbon intensity. So I've just commented it out, and I said, you know what, I'm not going to use WattTimes. I'm going to use my value for grid carbon intensity, which I'm going to say is 2,500. I'm just going to introduce you to this idea of defaults. Defaults are how you provide, if you've got something in defaults, they will be added to every single observation automatically for you. So a shorthand way of kind of really copying this data to every single observation. So I'm going to say the grid contents is 2,500. Let me move that to the top of the screen. And I'm not going to run it again. Am I? Did I? Yeah. And so now when I go here, you can see that, well, it's been removed from the pipeline. I've added this in. And if I go to some outputs, hopefully, you can see it now shows this is the grid carbon intensity it used. And very importantly, if you remembered previously, it was kind of like 0.31, and now it's kind of gone up significantly because I've chosen a bigger value. So I've changed an assumption that someone had in their calculation, and I've rerun it. This is the beauty of it. This is the beauty of kind of this transparent approach that we're advocating for here. You don't tell somebody your number, you give somebody your manifest file, and they can put their assumptions in and challenge you and question you, and hopefully help everybody get to a better understanding of what's going on. Because oftentimes it's not the one's right and one's wrong, it's different opinions and different approaches and different coefficients. There's other things I can do here, like I could actually, I'm using the Teeds curve. The Teeds curve is a model that, given the utilization, estimates energy consumption. So it's one way you can do that. I can see straight away, just by looking at it, when I get sent these reports, I don't know what model someone's used. I can see here straight away, okay, you're using Teeds curve. Great. I understand Teeds curve. I know what it is. But it doesn't work for me, actually. I want to use a different one. I want to use something called Boa Vista. Boa Vista is another service. It's a third party. They have their own API, and they're a great organization. It's a non-profit, and they've got their own model for estimating energy from utilization. I haven't tried this part of the demo yet. Let's see what it says, because I'm hoping it'll error. Good, it'll error. So you can see here, it's erroring out, and it's saying CPU name parameter is required. And that's because, the Boa Vista CPU just needs a little bit more information to work. It has some other inputs. It needs a CPU name parameter, but unfortunately, when you ask Azure, like, what is a CPU that this instance is running, it gives you, it could be one of these. It could be one of these. We don't tell you, it could be one of these. So, but Boa Vista needs an actual CPU name. So what I want is I just want to extract out this first piece of string and use that. So for that, I can just use a type of plugin called a regex plugin, which just basically parses that string and just extracts out and gives me CPU name. Just to shortcut it a little bit. It also needs some sort of field called number of cores. And I'm going to use this one, parse number of cores, which divides this value by 2 and outputs it as CPU number of cores. So this is kind of one way you might need to just massage the data a little bit to get it from one plugin to another. You're just inducing the parameters to kind of like get them to one place or another. So I'm going to add both of these and rerun it again. Fingers crossed. Okay, that worked. The numbers you're going to see are wild. So just give me a second. Here we go. Wow. So the anyway, let me say what's going on. So it extracted out CPU name and it put it here and number of cores. The carbon number does seem rather high, and we're kind of investigating what's going on with the Boa Vista API. So this is jumped up like 200%. Boa Vista, we do expect it to be higher because their fundamental methodology of measurement is completely different. And this is kind of the challenge that we're faced in this ecosystem that we're in. It's not the case that the Tees model is wrong and the Boa Vista model is right. It's a case of they just work differently. The Boa Vista model is estimating something called primary energy, which is a completely different way of looking at energy and what energy is than the Tees model. So so it's just different approaches. That's what we say. It's not like one's right and one's wrong. It's like, what's the opinion? And by having it all clearly laid out in a manifest file, I can clearly see which approach you're taking, and I can make my judgments based off of that. There's some questions in the chat. Joseph, why don't you yeah, but we've got some answers for those, which is very good. So let me, is that everything I wanted to explain here? Yeah. So that's there it is. That's the real power of the manifest file, is you're sharing your workings out, being transparent. Other people can adjust, change the model, do what they want to do, and really, it's that transparency. I always say, like, people say, like, talk about, if you're fully transparent, you can't be greenwashing. If you're transparent, you can't be greenwashing. The worst you can be accused of is being wrong about your assumptions. But the way I say it is it's just you have a different opinion for how to measure something. If you're transparent, how could you be greenwashing? So the future we want to have is one where everybody's fully transparent, but everybody's got manifest files. Every piece of software, every release has a manifest file which says, well, these are the emissions of this piece of software. And you disagree, fork it, use your own models, do what you want. But this is how we believe we want to measure it. How am I doing with time? Okay, I'm very delayed. Oh my word. I'm going to rush through the rest. So let me now talk about, like, computing a manifest file from scratch. So I'm going to be in my same folder because I still need to use Impact Framework and still need to run all those commands. I am going to just delete this one because I made it earlier. And I'm going to create a file called a blank one. And I'm actually, for now, I'm just going to like paste in just some very, very simple, a very simple manifest file right now. Here we go. Just going to make that pretty small. So this is the simplest. This I'm not even 100% sure this will run, to be honest with you. But this is a very, very blank manifest file that I'm going to start off with, and I'm going to start building it up to measure my application. I'm going to cheat a little bit. No, I'm not going to cheat a little bit. I'm going to add the first one I want to add which is called mock observation. It's going to be quite a big piece of code I'm going to paste in. I'm going to explain in a second. So if you look in the top in the head section, there's this initialize section and there's plugins. Every single plugin, every single plugin that is used inside the manifest file has to be configured here. Before you use it, you have to configure it. And Impact Framework loads all the plugins dynamically from the file system. So I'm going to say I want to use a plugin called Mock Observations. This is where Mock Observations lives. It's a separate package. It's not part of the Impact Framework CLI. So if you're using a plugin that someone else has created, you need to install that locally. So I've already got it installed, but I would type npm install and then this. In fact, I should have showed you this before. You needed to run that for the other one as well. But I would run that. And as soon as you can run that, as soon as you install that, then Impact Framework will load that package dynamically whenever it goes here. We're going to call mock observations. And what mock observations does is it just generates some data for you in a useful way. It's a testing tool, but I think it'd be quite useful to you if you're playing around with the manifest file. It's quite useful to be able to generate data and then see how pipelines change, rather than having to edit lots of lines in a manifest file. So what mock it just creates a set of fake observations. So we've got global configuration here. So this configuration is global configuration for that plugin that I've just configured. I'm saying from this timestamp here to this timestamp, which is an hour later, that's 6 minutes, isn't it? Yeah, every 6 minutes, or maybe I'll make that 5 minutes actually. Is that 5 minutes? Yes. So every 5 minutes, I want an observation in 5-minute buckets. I mentioned before that there are components. So I'm going to say this is one component that I want you to generate observations for. So for this component, I want an observation every 5 minutes for an hour. And generators is how you actually generate kind of like the parameters for it. So there's a couple of things which are static, which will just want copied into every single one. But the really important one is I want CPU utilization. I want that to be a random number between 1 and 99, and that's how you would configure it there. There's a lot more to the mock observations plugin, and I recommend if you go to the doc site, you can find links to the mock observation plugin and find out more about how to use it. It's a very useful plugin. So here, typically there are these types of plugins that we call importer plugins. And they import data from something else. We've got an Azure importer plugin, which imports data from Azure, which you can then run a pipeline on. So mock observation is kind of like simulating what an importer plugin might do for you, to pull those observations in. So it's very useful from that perspective. And I think that's all I need to have. Oh, of course. I also need to actually make that plugin active in the tree. Now, before you saw a tree, I had like lots of groupings underneath there. You don't need that. You can just run on the root node. So on the root node, I'm going to add a thing called pipeline on 2. I'm going to say what is the plugin I want to run on this pipeline, and I'm going to call it mock observations. And I can put inputs. I don't need to, but I'm going to put inputs there as well. But there's no inputs there. So now I'm just going to run this. Oh, I should change the name of it. Let me call it that. And then what am I calling this? This was first. Fingers crossed. Did that work? That was too quick. No, it wasn't. It was perfect. Well done, Asim. Here we go. So now I've computed this. So now what's happened? So you can see I've run it. It's now the inputs are null, but the outputs of the mock observations plugins. The outputs of this. It's generated, timestamps, the name, the cloud instance type, well, I need this for now for the geolocation, but more importantly, the CPU utilization is this random number it's generated. Brilliant. Now let's induce that from this to Carbon. What are the things we need to run? Well, to get from utilization into Carbon, we would probably want to use a Teeds curve plugin, as I mentioned before. But that actually needs some extra data. Like, what is this? I need to know what is the CPU? What is the actual CPU living under this instance type? Like, what exactly? It's just a string from Microsoft. So that is actually quite an interesting challenge. And one of the things we noticed a lot when we were investigating this space a while ago, which is that it's really hard to find a consistent, centrally localized data source where somebody's gone, this instance type from Azure is this CPU, this TDP, this number of vCPUs, all that other information. So what we decided to do is we created our own plugin called Cloud Instance or Cloud Metadata, and it is a manually maintained list of all the instance types from all the clouds with a whole bunch of metadata, which is very, very useful in computing impact in a variety of use cases. So it's a very common plugin to use if you're measuring something in the cloud. So all I have to do to use it is I've just configured it there. That was all the configuration. It's part of our standard library. IF plugins is what we call our standard library of plugins. So all I need to do is then add it to here, and I'm going to do cloud metadata. Oh, I've done it again. All the bloody time. I've just edited the output file. I did it like 15 times this morning in the other demo. You will do it millions of times. Don't know how to solve it. So I was editing the output file and was going to get overwritten, but I'm editing the input file. So let me just add that again to the pipeline and rerun. Okay. Now I'm going to go to the computed, and you can see the plugins there. You can see the inputs and you can see the outputs again. But now you can see there's a whole bunch of other metadata which has been added, and that's what the cloud instance metadata, the cloud metadata plugin did. It's very useful. If you've got cloud vendor and cloud instance type, it will look up in our data set and it will return all this very useful data, which is very useful for computing impacts. Okay, but it's not enough. I need to actually still get from utilization to, let's start off with energy. Now I'm going to use the Tees curve plugin. It's a very common approach that is used a lot of time. It's not it has its own downsides, it's serious downsides. It's a very generalized approach, but it's very easy and it's very simple. So I'm going to install that one. For this one, it's actually located in something which we call the unofficial plugins. These are plugins that we kind of maintain, but we Tees is an organization, so we hope if someone's from Tees is listening that they take it over. But in the meantime, it's one of the plugins we actively maintain actually. So I'm configuring it here. And again, this has got some configuration, which is kind of the method of interpolation. It's all in the docs regarding what choices you want. And again, all I have to do now is I add the Tees curve plugin and to the pipeline, and then I compute. Oh, have I just done it again? Okay, I've edited the output file again. So let me just put it there and then add it to the pipeline. Oh, I'm so late. I'm running very far behind. Boom. I might zoom through the next couple, to be honest with you. Compute and look at the computed. And now you can see I've added CPU energy. So Teeds curve takes in like this information and the utilization. And with those two bits of thing, it pumps into a model and it outputs an estimate of energy. So now we have an estimate of energy for this observation, for this time period, for this server, for this instance. In the interest of time, I'm just going to zoom through some others. I do apologize. I think I need to be quicker at the start of this demo, but you kind of starting to get the feel for how this works. I've just added a couple more plugins. The what time one I mentioned before, which kind of gets the grid carbon intensity. And then to actually get carbon, what you do is you multiply grid carbon intensity by CPU energy. There was a question there before about what is the units of some of these values. And that's one of the things that we've standardized. If you've got CPU energy, it must be in kilowatt hours. If you've got grid carbon intensity, it must be in grams of carbon per kilowatt hour. And by standardizing the units, it makes everybody's lives easier. So it makes your life as a user easier because you're not worried all the time, and it makes lives of plugin developers easier because then they don't have to think what units is this in. Just you always know what units something is in by the title, and there's a place in the repository where you can actually see this string, this description, this purpose, this units. So we've got all of that, and I consider this to be like one of the important steps in the standardization process. So that's all there. Let me add them here very quickly. Quick caveat: what time is an API? So I the credentials for this API I've set up as environment variables locally. So you don't have to things like credentials you don't want in your manifest file. You want to store them as environment variables so that yeah, so that you know you're not you're not sending somebody a password. So I've now added all these in here. Run the manifest file. I've done it again. I've done it again. Oh my word. Done it again. Okay, let's do it. Let's edit the right file. Um, what time? Operational carbon. Here we go. Computer.yaml. And you can see now we've got down to carbon. So this is 5 grams. These are much beefier servers. This is 5 grams for that 5 minutes. This is 4 grams for that 5 minutes. So now we've done what we did before. We've built our manifest and we've computed. Oh, Marcus is letting me know I'm in computed again. Thank you. So that's how I've made my first manifest file. And what I would do is I wouldn't tell you my carbon's 4 grams. I would send you the manifest file, and these are all my assumptions. You like them? You want to use them? You want to do something with them? You go for it. We also have like I'm not going to show you right now at a time, but we also have features like aggregation. So we'll actually sum all this up to a total value, and so you can see the total value for the whole application and totals by time as well. What's coming up shortly is export to CSV, which is going to really help you kind of visualize. It's hard with the YAML to visualize some of this stuff. Yeah. Well, maybe I've answered your question, Klaus. We've had I think the CSV export is going to be it's quite a useful tool to visualize things in a more human readable way, even though YAML is pretty human readable. But even at this, well, anyway, won't go to the YAML JSON argument yet. Okay, now we've done that. What I want to do is I actually want to create my own plugin. I want to create a plugin because I need CPU energy to actually be output as energy. I just need a quick plugin which can just turn CPU energy to energy. It doesn't exist right now, so I'm going to write plugin to implement it. How I would probably start this off is let me just like write. Oh, I'm in computed. Oh, let me just write here. How would I want to kind of load? It doesn't exist yet. How would I want to use and load this plugin? So I probably will call it copy plugin. And FYI, these titles here, they can be anything. They can be copy plugin asim. They're just descriptive text that you use in your pipeline. So you can name them whatever you want. The important thing is that um, they're all uh, uh, this is the important thing. Like we know what it is. We know what this is. So I want to have a create plugin called copy plugin. I'll explain method in a second. This is the actual name of the module. So if I was doing npm install, I would type npm install copy plugin eventually, but I'll show you how to do this now as you're developing on your computer. And the configuration I probably want to have is like, I probably want to copy a parameter over, but maybe I want to delete the old one. So maybe I'll have like keep existing is equal to true if I want to keep it, or if I want to set that to false, maybe I want to delete it. Let me say it's a false here for now. I'll probably want to delete the old one. And maybe I would add it to the pipeline at the end. So maybe add it as the pipeline minus copy plugin. But also I probably want some specific, config at a more local level. So I showed you before global config, but you can also have config at every node in the tree can have its own separate and unique config. So I'm going to add config for copy plugin. And this is how I separate the config for copy plugin versus everything else. And, I probably want to say, this probably isn't how I'd implement it in real life, but it's good to demonstrate config. I'm probably going to say like, look, copy whatever's in CPU energy and pass it to and output it into a field called energy. Okay. So this is how I'd want to use the copy plugin in my manifest file. Let's actually talk about um, uh, how to actually make that plugin. Okay. So and it's a bit, you have to kind of like bend your mind a little bit because you're working locally on your machine. So I need to like link my local plugin to what's going on here. So how would you do that? So where you would start off with, that's from this morning. Let me start off with here. So what I would do is I'd create a folder where you want to create your plugin. It can be wherever you want it to be. And then type npm in it. So it's got to be JavaScript, and that creates kind of like the place where you want to do your work. It typically will create it without a JavaScript file. I'm not going to type it because I don't want to ruin the. I'm scared I'll ruin the demo at the last minute. And then you probably want to start off. You want to have an index.js file where you want to put your code in. But the next thing you want to do, and this is where things get quite interesting, you want to type npm link, right? npm link tells JavaScript that you're working on a local package and you want to use it somewhere else locally on your computer. So kind of linking to things together. So you type npm link in this one, and then you would go back to where I'm going to run it from. So this one. And I would to tell this place that I want to go there, you do npm link copy plugin. Okay. So then you're telling this, I want to link to copy plugin, the one that you're working on locally and use it here. So that's how you would connect both of those together. This is actually, it's not too bad. It's a very easy way of working. You're developing a plugin. So it's a very easy way of developing it's one of the easiest ways I think of developing this stuff here. I won't need that or that now. So I'm going to type some code into here. And this is kind of the simplest bit of code you can have to start writing a plugin. So I'm going to create a function. It's called copy. It gets passed in the global config, and that is the global config that you configured at the top of the file. We have a metadata object that you should return. So right now you just have to say kind of execute. But in the future, as we expand the functionality of Impact Framework, there'll be other metadata we might ask you to return, and then we'll treat those plugins in a slightly different way. So we're leaving that as a future-proof thing, but you do have to return a metadata object. You create another function inside that. We code in a functional programming manner. So if you use the functional program, this is functional programming. So you create another function called execute, and that function takes the inputs. So those observations, the array of observations, that's what gets passed into inputs, and also that config, which is that local config I just showed you in the other file. Right now I'm just logging it so you can see what's gonna happen, and you return an object which is like the metadata plus the execute, and you just export it out here. So this is the very basic plugin that we're going to use now. So now let me go back to the other place here. Let me run it. Fingers crossed. Hey, yes. So you can see here, this is now being logged out from the copy plugin. So you remember I told you it has inputs. The inputs is that entire array of all the inputs that are being passed into this one. And because it's at the end of the pipeline, it's getting passed everything from the plugin just before it. And you can see right at the end, it's also printing out the parameters, the local parameters here. Okay, it's getting printed out there. And somewhere above it, it'll when it got initialized, it would also print it out somewhere to keep existing. I can't see it there, so hopefully that did. Okay, I'm not going to waste time. It printed that out as well. Now let's start fleshing out that plugin a little bit more. So it's going to do some work. I'm just going to copy and paste this whole block there. Uh, uh, in fact, I'm going to zoom ahead and do the last. I'm going to get to the file. Get to the file. Okay. I'm going to zoom ahead and I'm going to, here's one I baked earlier situation, but it's not that much code, so it's okay. So I'm just going to paste in the whole kind of finished logic of this thing. So you can see my execute function. I'm reading a couple of things. I've got the global config. Remember that keep existing was in the top of the file. I've got access to it here. So even in my execute function. So I want to grab whether I want to keep existing. I'm grabbing the from parameter from the config. I'm grabbing the out parameter from the config. So now those are all available to me in my computation. I'm then looping through the inputs. And I'm effectively like copying whatever is from this and I'm pasting it to there. And in here, I'm doing the business of like deleting the existing value if I wanted it deleted. And I'm outputting everything back out to the thing. I'm actually going to comment out this line just because I think it'll be interesting to show you the impact of this line here. So I'm outputting out kind of the output value. And I go back to here. I run it. I can look at the computer. Okay, it's run, but it's done something very interesting. It's just printed out all the for the outputs, the observations are just energy, nothing else. And we're now missing all that other information. And that's because each plugin is actually for every plugin you have to output what you are given as inputs, as well as the extra stuff that you've wanted to do output as well. The reason behind that is we want plugins to be built, or there's reasons to have plugins which overwrite values. There's reasons to have plugins which might filter some of those values and only send a subset out. So yes, there's a useful feature there. So that's why you have to output the inputs. And so now if I go back here, I head it out, and there you go. Now, there you go. So what this plugin did is it copied CPU energy to energy and it deleted the old CPU energy. There's a very quick and easy plugin. Obviously, you can build plugins that are a lot more complicated than that. I just want to show you kind of how you would write a plugin and how easy it was to write a plugin, to be honest with you. All of your logic goes in this little execute function. Impact Framework handles everything else, but as long as you just get some inputs, get your config, do what you want to do to output it, Impact Framework does everything else and kind of joins it all together. So that's that. Very quick reminder by the end, you know, the reason we kind of like went through this is that this is what we're running for the hackathon. This is the tool for the hackathon. If you're interested in taking part in the hackathon, please go to hack.greensoftware.foundation. Just sign up. As I said before, I think about 45,000 prize fund, and there's just a lot of useful stuff going on there. And you want to find out more about and if you're ready to kind of like propose something, please. I'm so excited. We get so excited because there's so many interesting ideas people are proposing and things we never even thought of. So if you've just got an idea, roughly, vaguely, even vaguely about what it is that you want to build, post a new issue here, and we'll weigh in and we'll you know, if you don't want any guidance, we won't give you any guidance, but we might give you some guidance and let you know. Impact Framework is very new. We're aware of that. And finally, I'll send you the link to the Impact Framework docs again here. And that's where you can find out more information about it. We're out of time now. We are running 2 more of these sessions next week. So if you've got colleagues or you thought it was useful, please share it out to other people. The best page to share out is this documentation page because we have the links to join here. Please share it out. Please let other people know. Please spread the word about Impact Framework if you think anybody else will find it useful. Hope you found this useful. And that's it. There is a question? Is there a question that I have to answer?
Yeah, there is. I was just starting to type it, but if you want to talk, then that's great. The question is, are you planning on adding statistical analysis, like error propagation? The output should ideally be a distribution of values. Or do we account for that?
Do you have an answer for that?
Well, my answer really was that our plugins are basically a wrapper around existing models. So we pipe whatever the existing model outputs, we pipe back into Impact Framework. There's nothing stopping anyone building any kind of plugin, very, very complex ones, very simple ones. Right now, quite simple, and they return single values, but that doesn't always have to be the case.
Yeah. Yeah. And you could write a plugin which measures if there's a distribution within a previous observation, you can write a plugin which measures it, and things like that. So yeah. Thank you, class, for the questions. I have to run because I've got children, small children, to pick up from places. Thank you all. Thank you all for attending. Please stay in touch. And yeah, if you're trying out for the hackathon, good luck, and we'll be in touch. Thank you. Bye bye.